This is a continuation of the video about factoring methods, where we're going to be deciding when to use what, and we're going to compare different methods I've seen over the years. So this is the flowchart we're going to utilize again, and this time we're provided with this question up top. We always start with deciding if there's anything in common to pull out as the greatest common factor. Well, we have a 6 that divides into all three terms. Whatever you divide by, you have to multiply. Then the 6 in front stays as the greatest common factor outside of the bracket, and inside of the bracket you put your leftovers. So these divide out and give this result, so you can check that this is true. Next, we're going to see whether this bracket on the inside could be factored more. It is a trinomial, so we're going to check the variable pattern. The variable pattern does work because we have even exponent at the beginning, no exponent at all on the variable because there's no variable in the last term, and the middle term has half of this particular exponent too, so this is x to the 1. So it does work out, and because this trinomial here doesn't have a coefficient on the x squared term, this is a simple type of trinomial. Most teachers show the sum product method. I will show you this method as well, but I have a favorite method I call the crisscross method that I'm going to show you as well for comparison. So here's what we had before, just transferred here, and let's do method number 1, which I call the crisscross method. So we're going to take this trinomial and we're going to pull out all the possible factors of the first term. Well, 1x times 1x is x squared. So you want to split up the variable evenly. So if this was x to the 4, you'll have to have x squared, x squared. Next, you're going to do the same thing with the last term. So what multiplies to get 12? 1 and 12 do so, 2 with 6 do so, 3 with 4 do so. And then what you want to do is ask yourself, what about the types of sign do you need here? Positive 12 could be 2 positives multiplied together or 2 negatives multiplied together. Because our result is to be an addition of this middle term, negative 7x, we will have to have 2 negatives on all of these combinations over here. So here are the negatives. And then we're going to do the crisscross. Technically for this question, because 1x and 1x here, these are symmetrical, it really doesn't really matter whether we crisscross here, but because this method is going to be used on other types of questions, it's best to remember the steps that work all the time. So our goal is to try a combination, to multiply the combinations and add the results so we can get this middle term. Let me demonstrate. So we're going to start with 1x multiplied with negative 12. So 1x times negative 12 is negative 12x. Remember this number or expression in your head. Then we're going to do the same thing with 1x with negative 1. And so that would be negative 1x. So then you're going to add the results. We have negative 12x this way and negative 1x this way. When we add these two, we get negative 13x, which is not what we want. We want negative 7x. So then you move on to the next combination. Now, from practice, let me tell you the following. Whenever you're trying these combinations, I would suggest that you try numbers that are close together, like this 3 and 4, because most likely that's the combination that would make this work. Not all the time, but usually. So let's try this one next instead of this middle one. So 1x with negative 4, that's negative 4x. Then 1x with negative 3, that's negative 3x. So negative 4x and negative 3x added together do give us this negative 7x. And so the result would be this combination with that combination together. And don't forget to carry down the 6 in front. And then record x minus 3 and x minus 4. So that's the crisscross method here. Let's do method number 2, which is pretty much just, you'll get the same result as this, just different notation here. So you would basically think of this middle term as the sum and this last one as the product. And you have to come up with 2 numbers that multiply to 12, but at the same time add to negative 7. And as you could see from previous answer, that negative 3 and negative 4 is the numbers that do so. So it seems like this is an easier method. However, crisscross, in my opinion, is better because it also works for complex trinomial factoring, which is our next thing. So let's take a look at this example here. We try to see if there's a common factor, GCF, to pull out, and there isn't. So then we see that it's a trinomial, so we check the variable pattern, and it works. And this time it is a complex trinomial because the coefficient on the x squared term is not just 1. So most teachers here do something called decomposition. I'm going to show you decomposition method. I'll show you crisscross method, and actually I'll show you 2 more methods that I've seen on the internet that were interesting, so you get to choose what you prefer. So let's start with method number 1, crisscross. Let's start listing off factors of 56. I'm not going to record the x's anymore. I'm just going to record the numbers because this is just going to be my rough work. So 56 divided by 1 divides in evenly, so that's one of the combinations. 56 divided by 2 divides in evenly 28 times, so that's another combination. 56 divided by 3, you get decimals, so you skip that. 4 with 14. Then 56 does not divide by 5, does not divide by 6. The next number to try is 7, and 7 divides it in evenly with the corresponding factor of 8. So you have now exhausted the list. There's nothing else to try once you arrived at a corresponding number that's close together here. Then you list off factors of 2, 1 and 2 with a negative somewhere. I'm going to choose to place the negative on the 2, but if it's in the wrong spot, I'm going to erase and put it elsewhere. So as I said before, we're going to try combinations that are close together. So the 7, 8 is the first one I'm going to try. And if that one doesn't work, I'll expand my search to 4 with 14 and so on. So we have 7 times negative 2. That's negative 14. Remember that. 8 times 1. That's an 8. Remember that. So we have negative 14 and positive 8. If we were to add these together, we would get negative 6. This is not the middle term, so that one doesn't work. And another thing you want to try with complex trinomial factoring, before you go on to bigger numbers actually, you want to reverse the order of the shortest list. Because me placing 1 on top and 2 on the bottom, well, what if that's not the right combination? So I'm going to change it and put negative 2 on top and 1 on the bottom. So you don't want to reverse the longer list. You want to take the shorter list and just do that before you move on to bigger numbers. So let's try this combination next. So 7 with 1, that's 7, remember that. 8 with negative 2, that's negative 16. So positive 7, negative 16. Yes, that does give us negative 9, this middle term. So we can circle this combination. Don't forget about the x's. 7x with 8x together make 56x squared. So we need to have the variables there. On the second combination, there's no variable on 2, so there's nothing to be placed there. And another thing you want to know about crisscross factoring for complex trinomial factoring. So if there is no, if there is a coefficient on x squared term, is that when you're doing trial and error, you do it in a crisscross fashion. And then when you're recording though, you have to record top with the top, bottom with the bottom, so you record it across. Technically, you could have done it vice versa. You could do trial and error sideways, but then record in a cross method, up to you. So let's record it. So 7x with minus 2 go together as one factor, and 8x with plus 1 go in as the second factor. Before you move on to another question, you should always be checking this with distribution or FOIL method. So if you were to expand 7x and 8x multiplied together, gives us this first term, no problem. Then when you do the outside and the inside of FOIL, so 7x and 1, that's 7x, and negative 2 with 8x, that's negative 16. So if you were adding these together, you should be getting this middle term. And positive 7x and negative 16x do give us this negative 9x in the middle. And then last times last does give us this last term. So always do this check because it is important. Now I'm going to show you, for comparison's sake, the decomposition method. which most of the teachers go this route. So in order for this decomposition to work, you have to remember the following for complex trinomial factoring. You can't just do sum and product as we've done before, so this last number cannot be just your product anymore. You have to multiply 56 with -2 together, so that's the a and the c together, that will be the product, and the sum would still be this middle term. So let's do that for our question. So 56 times -2 is going to be -112, and the middle number is -9. So we're going to find the combinations that work, and we're going to put the two numbers in here in this x. So it's not like you get out of trial and error with this method. You still have to do trial and error, but you'll end up having way more steps, I think, in my opinion, than the crisscross method. So watch me do this. So we need to list all the factors, or at least try all the factors of this product. So why do we start with the product? Because there's infinitely many numbers that give us -9. For example, -9 and 0 add to -9. -8 and -1 add to -9, and so on. So you never want to start with the sum, because that's an infinite list. So starting with the product number, let's on the side list all the combinations. So 1 divides in, 2 divides in, and the negative could have been on the other side, and so on. So I'm going to just go through this. The reason why I've circled this one, because out of all the combinations, these two numbers, -16 and 7, if you were to add them together, will give us this sum number, -9. So what you want to do is now record these -16 and 7 as the two numbers we're going to be using in our decomposition. Why is it called decomposition? What you're going to do is you're going to take this middle term and decompose it using these coefficients. So first term stays, last term stays, but -9x is rewritten as -16x plus 7x. Now this looks like factoring by grouping. We have 4 terms, so you could group the first two together and common factor 8x out. We have 7x minus 2 left over. Then we have plus sign, and you might say, well, there's nothing in common here. Please still record plus 1 as if you're dividing by 1. So this bracket does end up looking the same as this one. So then in the end, you can divide out this common bracket out to get this result, which is the same as previous. So in my opinion, this takes a lot more steps, and it's not like you get away from trial and error. You still have to find the combination somewhere on the side to get the numbers to work. In grade 11, you will have questions where you would have to simplify rational expressions. So you're going to have this type of polynomial in the numerator and maybe another one in the denominator, and you have to reduce that type of fraction. And if you had to do this decomposition on every single one of those numerators, denominators, is going to be really crazy. So you want to be able to do it efficiently. So I would suggest that you do it with the crisscross method, but it is of course up to you. Let me show you another method. I think this particular one, somebody called it Australian method, so I'm wondering if someone in Australia was doing this. So the first part of it is actually the same as decomposition. You still have to find the two numbers that multiply to the first and last together, so a times c, and add to the middle term. So once you find that combination, so again, it's not like you get rid of trial and error, you still have it. Then what you do is you record 56x in the first bracket and in the second one as the first terms, but also divide by 56. So let me tell you the reasons why this is still valid, because 56 times 56 and then divided a single time by 56, you'll still have your original 56. And x times x will be x squared. So that part kind of makes sense. Then what you do is record numbers -16 and 7 as the second parts of each factor. Then you just common factor each of the brackets. So the first bracket would be 8 pulled out in common. In the second bracket, you have 7 in common, you pull it out. Don't lose the division by 56. And then you just do simplifications. 8 and 7 multiplied together is 56, divided by this original 56 on the bottom. They cancel out, or divide out, I should say, and so you get the result. And another method I have seen, again, starts in the same way, that you still have to find the negative 16 and 7 as before. But then, here's what they do. They take the first coefficient, so the a, and divide the numbers that you find. Then you take these numbers and reduce these fractions. So negative 16 over 56 reduces to negative 2 over 7. And 7 over 56 reduces to 1 over 8. Then what they do is they record the numerators of these fractions as part of your factors. And then the denominators, someone said bottoms up to coefficients. So the bottom numbers will have to go on the top, so 7 and 8. And then this method also will work, but you just have to kind of memorize exactly what numbers go where. And anyways, as I said already, my preference is the crisscross method.